Is it clear, board? Is board is clear? Mute lo undu. Hi, good afternoon. Mute lo undu. His voice is audible? Is it clear? Yes. Welcome to today's session. This is a binomial theorem, exercise 7.1. Can we wait two more minutes? 2 more minutes, we'll wait. Okay, is it? Just 2 minutes? Yes. I'll come back within 2 minutes. Yes. We'll start our session. Is it audible? Can you say once? Yeah. So, binomial theorem chapter, exercise 7.1, we are going to start today. So, actually, binomial theorem proof already discussed in the previous videos. Just you can watch it. That is the most important theorem. Then coming to exercise 7.1. So, there are mainly the total exercise 7.1 we are divided into 4 parts. There are 4 parts. Part number 1 is expansion model. Expansion model. There are 2 types of expansion models. Let us move to second one. After expansion model, that is greater or lesser model. Greater number or less number. Lesser number model. Greater number or lesser number model. Afterwards, remainder model. Then coming to last and final, some miscellaneous models. Okay, like expansion based only, some miscellaneous models are there. So if you focus on these four areas, exercise 7.1 is very easy for you. So first one, expansion model 1 and 2. There are two models. Second one, greater and or lesser model. Third one is remainder model, and fourth one is miscellaneous model. Let us move to the first one, is expansion model. Expansion model means you have to know the expansion of binomial theorem. What is the expansion of binomial theorem? A plus b whole to the power of n is equals to, you have to by heart this one, nc0 a power n b power 0 plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 into b square plus so on plus ncn a power 0 b power n. So very easy to remember this one. Why? Because if you by heart this expansion, very easy to solve the numericals. So how to remember the expansion, I'll tell you. So very simple, a plus b whole to the power of n is nothing but nc0. So a power n means a power n minus 0, n, b power 0, plus nc1 a power n minus 1 b power this one, plus nc2 a power this minus this n minus 2 b power this, plus so on plus ncn a power n minus n 0 b power this one. So very easy to remember. If you observe carefully, a power is decreasing, b power is increasing, 0, 1, 2, 3, so on n. b power is increasing, a power is decreasing. Similarly, a minus b whole power n expansion also you have to remember. A minus b whole power expansion is alternate plus and minus. The same expansion only, just alternate plus and minus. So let us start this one, nc0 a power n b power 0. Next, this is started with plus, right? Minus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b square minus, because plus minus so on, plus last term we don't know, nth term depends on whether it is even or odd. That's what minus 1 whole power n into ncn a power 0 b power n. Same expansion only. So better you remember the expansions, then it is very easy. So nc0 a power n b power 0 plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b square plus so on plus ncn a power 0 b power n. In the same expansion we written as alternate plus and minus for a minus b whole to the power of n. Now how we are going to evaluate the expansion, I'll tell you. I'll explain. So let us take a question. So the question is x square plus, this is your textbook question, plus 3 by x whole to the power of 4. X square plus 3 by x whole power 4. In this expansion, total, what is the expansion of this x square plus 3 by x whole power n? So let us compare this with a plus b whole to the power of n. You have to compare with this. Then if you compare whenever, so you can able to write very easily here. What is the value of a here? A value is x square. And what is the value of b? 3 by x. And the n value is 4. A value is x square, b value is 3 by x, and n value is the power, that is nothing but 4. So this can be written as, so a plus b whole power n expansion, right? So what we can able to write this one, nc0 a power n, a is nothing but what, x square whole power 4 into b power 0, 3 by x whole power 0 plus 4c1 x square whole power 4 minus 1, how much, 4 minus 1 and 3 by x whole to the power of 1 plus nc2 x square whole power 4 minus 2 3 by x whole square plus plus 4c3 x square whole power 4 minus 3 3 by x whole power 3 plus 4c4 x square whole power 4 minus 4 3 by x whole to the power of 4. That's all. So then this can be written as what? 4c0 value is 1. Then x square whole power 4 nothing but x power 8. 3 by x whole power 0 is 1 plus 4c1 is nothing but 4 because nc1 is nothing but n. X square whole power 4 minus 1 is 3. 3 by x whole to the power of 1 plus 4c2 is nothing but, do you know how to do 4c2? 4 into 3 by 2. This is nothing but 2 2s are 4, 3 2s are 6 into x square whole square into 3 by x whole square plus 4c3 is nothing but NCR equal to NC n minus r. This is nothing but 4c1 and hence the value is 4. X square whole to the power of 1 into 3 by x whole cube plus 4c4 is nothing but 1 into x square whole power 0 into 3 by x whole to the power of 4. Now this can be written as 1 into x power 8 into 1 x power 8 plus 4 into x power 2 3s are 6 into 3 by x plus 6 into x square whole square is nothing but x power 4 into 3 square is 9 by x square plus 4 into x square into 3 cube 27 by x cube plus 1 into x square whole power 0 is also 1 into 3 power 4 81 9 into 9 x to the power of 4. Then what is the calculation, final calculation? X square, x cancel with 1. So x power 8 plus 4 into 3 12 x to the power of 5 plus x square cancel 2 times 6 into 9 54 into x square plus x square cancel here. So then 4 into 27 108 by x. Sorry. 4 8s are 4 into 27 102 sorry 108 right 108 by x plus 81 by x to the power of 4. So this is the final answer. So this is the expansion for this one. It's a very simple model, simple logic also. Now if you take a minus b whole to the power of n, so what is the, how we are going to expand, we'll see by one example. Coming to next, one more question. For example, 2 by x minus x by 2 whole power 5. So I consider now minus a minus b whole power an expansion now. Now here also what you are going to compare with a minus b whole power n format. A minus b whole power n format means here what is the value of a? 2 by x. What is the value of b? X by 2. What is the value of n? 5. Clear? Same. We are going to compare with a minus b whole power n and hence this format. What is the format here? This is equals to nc0 5c0 a power n 2 by x whole power n b power 0 x by 2 whole power 0 minus 5c1 2 by x whole power 5 minus 1, shall I write directly? 4 x by 2 whole to the power of 1 plus 5c2 2 by x whole power 5 minus 2 3 x by 2 whole square minus 5c3 2 by x whole power 5 minus 3 2 x by 2 whole cube minus plus 5c4 2 by x whole power 5 by 5 minus 4 1 x by 2 whole to the power of 4 minus 5c5 2 by x whole power 0 x by 2 whole power 5. Alternate plus and minus we need to follow, plus minus then minus. Now this can be written as what? 5c not 1 2 power 5 by x power 5. So something power 0 is 1 minus 5c1 is nothing but 5 2 power 4 by x power 4 into x by 2 plus 5c2. What is the calculation for 5c2? 5 into 4 by 2. 2 2s are cancelled, 5 2s are 10. 10 into 2 cube by x cube into x square by 2 square minus 5c3. 5c3 is nothing but NCR equal to NCN minus R. 5c2. 5c2 is nothing but just now we discussed 10 into 2 square by x square into x cube by 2 cube plus 5c4 is nothing but 5c4 is nothing but what? 5c4 is nothing but 5c 5 minus 4 and hence 5c1 this is nothing but 5 into 2 power 1 2 x into x power 4 by 2 power 4 minus 5c5 1 2 by x whole power 0 1 into x power 5 by 2 power 5. This can be written as what? 2 power 5 32 by x power 5 minus, so x will be cancelled 3 times remaining 1 2 will be cancelled 3 times remaining 2 cube 8 5 8s are 40 by x cube plus 2 square cancel, then x square will be cancelled 2x, so 10 into 2 20 by x. Coming to next, 2 square will be cancelled here, x square will be cancelled, then 2 remaining here, 2 5s are cancelled and hence minus 5x. Then coming to next, plus what can I write? X cancel 3 times remaining, 1 2 will be cancelled 3 times remaining here, so then this can be written as 5 by 2 cube 8 into x cube minus x power 5 by 2 power 5 is nothing but 32. That is the expansion. Your answer also will get in terms of plus and minus, alternate plus and minus you will be getting. This is model number 1. This is model number 1. So in this model, so whenever you are going to take a plus b whole power n, a minus b whole power n, in these two situations we are explaining the expansion side. Now coming to next, the next model is they are going to give some values. So through the values the expansion they are going to ask. Which kind of questions they are going to ask usually? Let us see. Now model 2 is like they are going to ask this kind of questions. 98 power 5, 99 power 6, 102 power 3, 101 power 5. This kind of questions they will ask. What is the expansion of this kind of models? So very simple, just you have to know this is what you are going to write. 98 can be written as 100 minus 2 whole power 5. That's all. Then this can be written as 100, 99 means 100 minus 1 whole to the power of 6. You are going to write like this. Then what about this? 102 is given. 102 means 100 plus, this is near to 100, 100 plus 2 whole cube. You can able to expand like this. Then this is can be written as 100 plus 1 whole to the power of 5. So whenever you are going to write the first step is this one, then the expansion will be very easy for you. So let us solve this question. For example, how you are going to evaluate 102 whole cube? I will solve it now. (102) whole cube can be written as, just now I discussed, 100 plus 2 whole cube, right? So now let us compare with which format? Some a plus b whole to the power of n, right? Same, a plus b whole to the power of n. Then this can be written as here what we can able to write? A is equals to 100, b is equals to what? 2. A is equals to 100, b is nothing but 2. And what about n? N is nothing but 3. So now let us expand here what we can able to write according to a plus b whole to the power of n format. This can be written as n means 3 nc0 100 power 3 minus 0 2 power 0 plus 3c1 100 power 3 minus 1 into 2 to the power of 1 plus 3c2 100 power 3 minus 2 into 2 square plus 3c3 100 power 3 minus 3 into 2 cube. This is the final value. 3c4 this does not exist. Why? Because n should be greater than or equal to r. Now here very clearly 100 power 100 power 100 power 100 power is there. Let us simplify that one. So 3c0 is nothing but 1. 100 power 3, of course 2 power 0 is also 1, plus 3c1 is nothing but 3 into 100, 3 minus 1 is 2 into 2, plus 3c2 can be written as 3c1, 3c2 can be written as 3c, 3 minus 2 and hence 3 minus 3c1 and hence 3, this is 3 into 100 power 3 minus 2 1 into 2 square is nothing but 4, plus 3c3 is 1, 100 power 3 minus 3 is nothing but 1 because 100 power 0 is nothing but 1 into 8. Here all are positive signs only. Why? Because a plus b whole power n expansion. For example, if it is a minus b whole power n expansion, we need to write plus or minus. So alternate plus or minus. So then this is nothing but 100 power 3 can be written as what? So very simple logic. For example, if you don't know how to write 100 cube, so let us write down 100 cube can be written as, let us write down 100 can be written as 100 square whole power 3, that is nothing but 10 power 6. So this can be written as 1. So 1, 2, 3, 4, 5, 6, 6 zeros. So this can be written as 1, 1, 2, 3, 4, 5, 6. So this can be written as plus 3 into 100 square, 10 square, 10 square is nothing but 10 power 4, that is nothing, 3 into 2 what? 6, 6 into 1, 2, 3, 4 plus then 3 4s are 12 into 100 plus 8. This can be written as 1, 2, 3, 4, 5, 6, 6 zeros plus 6, 1, 2, 3, 4 plus 1, 2, 00 plus 8. Just if you add this part, you will be getting 102 whole power 3 expansion. In the same way, remaining all questions also like 101, like 101 whole power 5 they are given. So you are going to write just 100 plus 1 whole to the power of 5. Finish this one. So then coming to next, for example, 99 whole power 6 means you are going to write 100 minus 1 whole power 6. By that time you are going to apply a minus b whole to the power of n expansion. So this is what expansion related questions. There are 2 questions, expansion based questions, models. So that's what these areas are most important. Let us move to next area. Next model is the most important model, which is larger number. Okay, which is larger number? Which is larger from 1.01 whole power 1, 2, 3, 4, 5, 6. There are given 6 zeros or 10,000. So which one is larger? They are asking. So this kind of sums we are going to do very smartly. So we are going to do very smartly. So which is the larger means? So the question is 1.01 whole power, how much given? Almost 10 lakhs given. So 1 1.01 whole power 10 lakh or else 10,000, which is a larger value they're asking. So now how you are going to prove? Actually this value, you know, this is 10,000. Now what about your this value? You are going to prove this value is above 10,000 or below 10,000. Yes or no? About 10,000 or below 10,000. For example, if you prove this as 10,001, then this is larger. For example, if you prove this is what? 9,999, then this is smaller, this is larger, right? So that's what. So with a small expansion, by using expansion, binomial expansion, if you simplify this one, just we need to identify this is above 10,000 or below 10,000, that's all. So let us check here. So 1.01 whole power, let us count the numbers. Always 10 lakhs means we can't write properly. This is what? How many zeros total? 6 zeros. 1, 2, 3, 4, 5, 6 is equal. So what can I write? This can be written as 1 plus 0.01. Clear? 1 plus, how to split? 1 plus 0.01 whole power 1. 1, 2, 3, 4, 5, 6. This is the expansion. So in this expansion, this is of the form a plus b whole to the power of n. So it is of the form what? A plus b whole to the power of n. What is a here? Here, what is a? A is equals to 1. What about b? 0.01. What about n? 1, 1, 2, 3, 4, 5, 6. That is n. Now let us expand. NC naught. N is what? 1, 1, 2, 3, 4, 5, 6. C naught. Okay. A power. A means what? 1 power. Whatever value 1 only. That's what I am not writing. 1 power anything 1 into b power. B is what? 0.01 whole power 0 plus what shall I write here? 1, 2, 3, 4, 5, 6 10 lakh C1, isn't it? 1 power 10 lakh minus 1. Of course this result is 1 only into 0.01 whole to the power of how much? 1 plus this expansion is so on, it is going on. Then this can be written as what? Something 10 lakh C naught, whatever it is, NC naught is always equal to 1 only. So that's what this total result is 1 into something 0.01 whole power 0 is nothing but 1 plus 10 lakh C1 can be written as 10 lakh 1, 2, 3, 4, 5, 6 into 1 into 0.01 plus so on. This can be written as what? 1 plus this can be written as 0.01. So 2 zeros you need to keep left. So this is what? How many zeros will be there? 1, 2, 3, 4. 4 zeros will be there plus so on will be there. Then this can be written as 10,001 plus so on. Just by adding first 2 terms only, this result is 10 lakh 1. By adding first 2 results only, the result is 10,001. What about the remaining sum? So obviously this would be bigger than 10,000. Yes or no? So that's what we can able to write, which is greater than 10,000. So compulsory comparing to this value is bigger quantity. It's a big value. Clear, my dear? So let us move to next sum. This kind of model. One more sum. Which is larger? In your textbook, one more sum is given. 1.1 whole power 1, 2, 3, 4. 10,000 or 1,000. Again, the same logic I am going to apply. So what we are going to prove? Whether this is bigger or this is bigger, we are going to prove. This is what? 10,000. Sorry, this is what? 10,000. So 1,000 is bigger value, or else this quantity is bigger. We need to prove, isn't it, sir? So what our aim is what? This is 1,000 means this one you are going to prove 1,001 or else 999. If it is 999, this is bigger. If it is above 1,001, obviously this is bigger. Let us start your proof. Same as it is 1.1 whole power 1, 2, 3, 4. can be written as 1 plus, what shall I write here? 1.1 is 0.1 whole power 1, 2, 3, 4. This can be written as a plus b whole to the power of n. Understand? Here, what is the value of a? A is equals to 1, b is equals to 0.1 and n is equals to 1, 2, 3, 4. 4 zeros. 10,000. Now, can we go for expansion? What about this expansion, sir? This can be written as 10,000 C naught. 1 power anything 1. 1 power 10,000 minus 0. Not necessary 1 power anything 1 into. So 0.1 whole power 0. This one. Plus 10,000 C1 into 1 into 0.1 whole power. What shall I write? 1 plus so on. This can be written as 10,000 C naught 1 into 1 into 1 plus 1, 2, 3, 4. NC1 is nothing but n into 1 into 0.1 plus so on. This can be written as 1 plus 0.1 means cancel 1 0, then you are getting 3 zeros after 1 so on. This can be written as what? 1001 plus so on. So just sum of first two terms only crossed 1000. 1001 you are getting. So obviously the total summation is, of course, it will cross 1000. That's what this quantity is must be greater than 1000. Therefore, what we can able to write? 1.1 whole power 1, 2, 3, 4, 5, which is greater than 1000. So 200% is that result is greater than 1000, we can say. Did you clear? This is model number 2. Let us move to model number 3, that is a remainder model. This is the most important model in binomial expansion. Remainder model is one of the very important questions in your binomial theorem chapter. Let us move to remainder theorem. Let's see. Let's take the question. Using binomial theorem, prove that 6 power n minus 5n is always leaves remainder. Leaves remainder 1 when divisible by or divisible by 25. This proof can able to do in different methods also. That's what they mention. They will mention very clearly by using binomial theorem. So must and should you need to use by using binomial expansion only need to solve this kind of sums. So this kind of sums, how to solve means, this is what 6 power n minus 5n, what it is given, is always is equals to, leaves a remainder 1 it remains, plus it is divisible by 25. So 25 into something k. Divisible by k means 25 times will be exist. That is what the meaning. You are going to prove finally this one. This is your ultimate proof. If you want to prove this one, what you are going to consider means you have to know the formula for 1 plus a whole to the power of n. If you know that formula, it is very easy. What is the formula for 1 plus a whole power n? 1 plus a whole power n is nothing but, according to binomial expansion, nc0, 1 power anything 1 into a power 0 plus nc1, 1 power anything 1, so a power 1 plus nc2 into a square plus so on ncn a power n. So this can be written as what? So nc0 is nothing but 1. This is what 1 into a power 0 also 1. 1 into 1 into 1 is 1 plus nc1 into a plus nc2 into a square plus so on plus ncn into a to the power of n. That's what you write. So we know that we are going to write our known result. We know that 1 plus a whole to the power of n can be written as, what is that? 1 plus nc1 into a plus nc2 into a square plus nc3 into a cube plus so on plus ncn into a to the power of n. So now what we are going to do? So you are going to replace some value of a. Why? Because you want 6 power n you want. So here 1 plus a whole power n is there. If you want this is 6. What we are going to replace in place of a is equals to, you are going to take 5. If you take 5, 1 plus 5 is nothing but 6. 6 power n you are going to get. That's what, if you replace a as 5, 1 plus 5 whole to the power of n is equals to 1 plus nc1 into 5. In place of a, replacing 5 plus nc2 into 5 square plus nc3 into 5 cube plus so on plus ncn into 5 to the power of n. Now this can be written as what? 1 plus 5 is equals to 6. 6 power n is equals to 1 plus nc1 is nothing but what? n. n into 5 is nothing but 5n plus, you are going to take from the entire quantity 5 square as common. Can we able to take common? Here 5 square will be there. Here also 5 square will be there. Next term 5 power 4 will get 5 square will be there. Up to so on, here also 5 square will be there. So this can be written as nc2 plus nc3 into 5 plus so on. Wait. Then what can I write? Next step. Your next step is what? This is equals to 6 power n. 5n, keep it left hand side. Minus 5n is equals to 1 plus 5 square is nothing but 25. Let it be called this quantity is compulsory. It's a natural number or any number you get it. That is what k, where k is equals to nc2 plus nc3 into 5 plus so on will be there. Now this is what the proof. 6 power n minus 5n is equals to 1 plus 25 into k. So this meaning is what? 6 power n minus 5n is always leaves the remainder 1 and which is divisible by 25. So in this kind of model, one more question is there. That question is nothing but, let's copy. By using binomial expansion, we are going to derive one more question. Prove that 9 power n plus 1 minus 8n minus 9 is divisible by 64 where n is a positive integer. Where n is a positive integer. No, just now we discussed. So the thing is, what we are going to prove? 9 power n plus 1 minus 8n minus 9 which is divisible by 64 means you are going to prove 64 into some k. That's all. Okay, just now we discussed the formula. What we know? We know that what is the formula? 1 plus a whole to the power of n is nothing but what? nc0 plus nc1 into a plus nc2 into a square plus nc3 into a cube plus so on plus ncn into a to the power of n. Just now we discussed this proof. So now what we are going to do, So in place of n here, n plus 1 is there. That's what you need to replace n as n plus 1. So this can be written as, we know that what we can able to write? 1 plus a whole power n plus 1 is equals to, just replace in place of n plus 1. It is nothing but n plus 1 c0 plus n plus 1 c1 into a plus n plus 1 c2 into a square plus n plus 1 c3 into a cube plus so on plus n plus 1 cn plus 1 into a power n plus 1. This is the formula. By using this formula, just replace n as n plus 1. Let us move to here. Now you are going to prove this is 9. If you want this quantity as 9, what value you are going to replace for a? Put a is equals to what? Put a is equals to 8. If you take a is equals to 8, then 1 plus 8 is nothing but 9. Then 9 power n plus 1 you are going to get. Then what we can able to write? 1 plus 8 whole power n plus 1 is equals to n plus 1 c naught plus n plus 1 c1 into 8. 8 is nothing but, in place of 8 is a, in place of a is 8, right? Plus n plus 1 c2, n plus 1 c2 into 8 square plus n plus 1 c3 into 8 cube plus so on plus n plus 1 cn plus 1 into 8 power n plus 1. So in the same way, 1 plus 8 is 9, 9 power n plus 1 is equals to n c naught, n plus 1 c naught is 1 plus n plus 1 c1 is nothing but n plus 1 into 8 plus you are going to take 8 square as common from entire the equation. You are getting n plus 1 c2 plus n plus 1 c3 into, if you take 8 square common, into 8 plus so on. Then what we can able to write? What is the further simplification? It's very easy, right? 9 power n plus 1 is equals to 1 plus n into 8, 8n plus 1 into 8, 8 plus 8 square is 64 into, this is what, some constant, where k is equals to like n plus 1 c2 plus n plus 1 c3 into 8 plus so on. Then 9 power n plus 1 minus 8n, 1 plus 8 is nothing but 9, keep left hand side, minus 9 is equals to 64 into k. So what is this meaning? 9 power n plus 1 minus 8n minus 9 is divisible by 64. This is the proof. Okay. So this kind of this area is most important. Our three areas over. First one is expansion models. Two types we discussed, and the second one is what? Second one we discussed as, which models we discussed? Second one, after expansion, we are discussing the models are which one? Greater or lesser models, and the third one is nothing but binomial models. Now some miscellaneous models by using expansions only, so we are going to term number of terms and all, so that models I'll discuss now. Let us see. That is the last and final model. Find a plus b whole to the power of 4 minus a minus b whole to the power of 4. Hence, root 3 plus root 2 whole to the power of 4 minus root 3 minus root 2 whole to the power of 4 equal to dash. So this is a very easy question. Just you need to write the expansions of both a plus b whole power 4 minus a minus b whole to the power of 4. What's that? A plus b whole power 4 means 4c naught, a power 4 minus 0 4, b power 0 plus 4c1. This is positive, that's what all are positive signs. 4c1, a power 3, b power 1 plus 4c2, a square, b square plus 4c3, a power 1, b cube plus 4c4, a power 0, b power 4. A decreasing, b increasing. Plus or minus here, minus is there. So minus bracket begin. So now a minus b whole power 4. You need to write alternate plus and minus. What's that? 4c naught a power 4 b power 0 minus 4c1 a cube b power 1 plus 4c2 a square b square minus 4c3 a power 1 b cube minus 4 plus 4c4 a power 0 b power 4 plus minus plus minus plus. Once check it after writing this expansion, because alternate plus and minus whether we written or not, you need to cross check. Then what to do here? 4c naught a power 4 b power 0 plus 4c1 a cube b power 1 plus 4c2 a square b square plus 4c3 a power 1 b cube plus 4c4 a power 0 b power 4 minus 4c naught a power 4 b power 0 minus into minus plus 4c1 a cube b power 1 minus 4c2 a square b square minus into minus plus 4c3 a power 1 b cube, then minus 4c4 a power 0 b to the power of 4. Just you need to cross check whether the cancellation part. What are the cancellation part here? So minus 4c naught plus 4c naught term cancel, minus 4c2 plus 4c2 term cancel, minus 4c4 plus 4c4 term also cancel. Then what to do here? So how many terms are left? There are 4 terms. If you observe carefully, 4c1 terms are, there are 2 steps, 2 terms and 2 times repeated, and 4c3 terms also 2 times repeated. Then can we able to write 2 times of 2 times repeated it? 4c1 a cube b power 1 plus 4c3 a power 1 b cube. This can be written as 2 times of 4c1 is nothing but 4 a cube b. 4c3 is nothing but 4c4 minus 3 as per formula. This is 4c1 and hence 4. So 4 into a b cube. This can be written as 2 times of, you can able to take 4 common and a common and b also common. You are getting a square plus b square, and hence the final answer is 8ab into a square plus b square. Whenever they are asking the attached question, hence prove root 3 plus root 2 whole power 4 minus root 3 minus root 2 whole power 4 means you no need to derive once again, just you need to replace in this formula. According to this formula, what we can able to write? Just in this formula, you have to substitute a is equals to how much? Same format, right? A is equals to root 3 and b is equals to how much? Root 2 and n is equals to how much? 4. If you substitute in this formula, root 3 plus root 2 whole to the power of 4 minus root 3 minus root 2 whole to the power of 4 can be written as 8 into a into b. A is root 3, b is root 2 into a square plus b square. A square is root 3 whole square 3, b square is root 2 whole square 2. Then 8 into root 3 into root 2, root 6 into 3 plus 2 is 5. 5 8s are 40 into root 6 is your final answer. In the similar way, you are going to solve remaining sums also. So the other sum is given as x plus 1 whole power 6 plus x minus 1 whole power 6, and hence prove that root 2 plus 1 whole power 6 plus root 2 minus 1 whole power 6. This is also similar model only. First you derive this one. In that application, you need to substitute a value is root 2 and b value is 1 and n is equals to 6. Then you will be getting. And last and final model is one question is there. Afterwards, if you have any doubts, you can ask me. Final model, sigma r is equals to 0 to n. 3 power r into NCR. You are going to prove this is 4 power n. Prove that this is. Prove that question. You need to prove this one. So this is the question. Just you need to expand this one. Sigma r equal to 0 to n. 3 power r into NCR they are given. This can be written as. So sigma means summation you are going to write, and moreover in place of r we are going to take the values from 0 to n. That is what 3 power 0 into NC0 plus 3 power 1 into NC1 plus 3 power 2. R equal to 2 means 3 power 2 into NC2 plus 3 cube into NC3 plus so on plus 3 power n into NCn. For example, this can be written as 3 power 0 is 1, NC0 is nothing but 1 plus NC1 into 3 plus NC2 into just 3 square plus NC3 into 3 cube plus so on plus NCn into 3 to the power of n. If you observe carefully, just now I discussed the formula. It is nothing but 1 plus a whole to the power of n expansion. What is the expansion? This is 1 plus NC0 into a plus NC1 into a plus NC2 into a square plus NC3 into a cube plus so on. That is the expansion, right? So in this expansion, that's what this can be written as 1 plus a. What is a here? A is going on a square, a cube is going on, right? A whole to the power of what? En. This is nothing but 1 plus 3 equal to 4, 4 to the power of n. This is what your expansion. So by using this expansion, you can able to simplify and solve very easily all this kind of approach questions. Okay, this is what binomial theorem exercise 7.1. It's a very easy, right? So these 4 areas if you simplify and cover, then you can able to do very easily. So now if you have any doubts or anything, please let me explain. Yeah, any comments, anything else? If you want any chapter, you can text me. I'll come with one more session with live any chapter in mathematics, 11th standard and 12th standard. So definitely I will come with that chapter. And if you have any doubts also, you can able to ask me through Insta or else through Facebook or else through my YouTube channel. Okay, you can approach me through my YouTube channel. Hi sir, this is Gururaj Onkar. Nice to see you online. Thank you Gururaj. Anything special for JEE? So anything special for JEE they're asking, sir? Many JEE videos I uploaded, just you look at my channel. So JEE mains and JEE advanced videos also there. Just look at my playlist, you will be getting. Anjan is asking permutations and combinations chapter. Definitely I'll come with that chapter also once. So Mr. Naveen is, hi sir, how are you? Yeah, I'm very fine. Yeah. So ask any questions in this topic. In binomial theorem, if you have any doubts, you can raise, you can comment. So integration also they're asking. Integrals chapter, please. So integrals chapter means integration is a very big chapter. So which area you want, you specify, then I'll come with that particular area. Otherwise integration chapter is total complete 5-hour session. Total 5-hour session. Shortcuts in binomial theorem they're asking. Yes, I'm uploading shortcuts in binomial theorem. Already binomial theorem shortcut is uploaded. Shortcut 1 is uploaded, and also binomial theorem proof also uploaded. Just you watch it. So while doing, few people having doubt, whenever binomial theorem is using, by the time a plus b whole power and only 2 terms, by means only 2 terms will be there. Why we are going to move for more number of terms means, so binomial theorem concept is extension. Okay, after completion of two numbers or 2 things, we are going to extend the topic also. That is there in the syllabus in the JEE. That's what I was taking, that kind of examples also. I hope you understood. Who are asking me? No need to sit in first bench. So keep going like this, sir. Okay, Tejita garu, keep going like this. Thank you so much, Tejita garu. Next, what is? Thank you. So not only now in this live session, anytime you can ask me any doubts regarding related to mathematics. So I'm ready to explain, no issue for that. Okay, I hope it's clear with this. I hope you enjoyed the class. This is a session for binomial theorem. So definitely I'll come with you new session, new chapter with your interest. Definitely I'll come. Okay, so thank you so much, friends. Thanks a lot. Thank you.